All right, we don't have a lot of time for this one, so let's get going. 1, 2, 3, 4. Chapter 3. What did you do to me? Let's take a test. Behind on this, so we're going to try to do it all in one take. Mistakes and all. Let's see what we can do. All right, so the first one says use a diagram to represent the following division problems. I made a mistake. Originally, I changed it on the online one, but I had to rewrite it by hand here. So we have 1/2 divided by 4. So the kind of diagram we're going to use a box. And we're going to start with a box that is split into halves. And I'm just going to shade in 1/2 of that. I'm going to go ahead and do it in green. So I have 1/2. That represents 1/2. Now I want to divide by 4. So I'm going to go ahead and in the other direction, I'm going to divide it into 4 sections. So I'm going to go 1, 2, 3. And that makes 4. Pretend those are all even. Sorry that they're not. And I want to divide it into 4, so I'm going to take just 1 out of those 4 right here. In this section right there that's double shaded represents 1 out of 8 total, so it's going to equal 1/8. And if you go ahead and flip and multiply, you can figure out that it is the same. It should be 1/8. All right, letter B, same kind of thing. We're going to start with 4/5. So I'm going to go ahead, I'm going to draw a box. I'm going to split it into fifths. 1, 2, 3, 4, 5. And I need 4 of them. So we're going to shade 4 of them green. 1, 2, 3, and 4. And then I want to divide it by 3. So I'm going to divide it into thirds this way. And I'm going to take 1 of them, which means I'm going to double shade all these ones at the top. So that would be 1/3 of that group. And I now know that I have 15 total, and I have 1, 2, 3, 4 double shaded. So it's going to be 4/15. All right, moving down to number 2. It says solve for the missing length of the tightrope. Write an expression for each length of the tightrope, and then combine the 2 expressions into an equation. So I'm going to go ahead and solve for the missing part of the tightrope first. So I look right here. I know that I have an X and an X on the same, or on each one. So I can kind of just ignore those ones because they are both there. And then I know that I have a 20 and a 28. So the difference between 20 and 28 is 8. So I know that these 2 X's right here have to equal 8. So then each one of those X's must equal 4. So we know X equals 4. That's for A. Now we're going to write an expression for each length of the tightrope. So for the top part of the tightrope, I have 20. I'm going to add X plus X plus X. You could also write that as 20 plus 3X. And for the bottom part of the tightrope, we're going to have 28 plus X. Finally, they just want us to combine the 2 expressions into an equation, so I'm just going to write the 2 expressions again. But this time there's an equal sign between them. All right, number 3. Rewrite the following fractions as decimals without using a calculator. We know that all division problems, or all fractions are division problems, and we know all division problems can be turned into decimals by just dividing the numerator by the denominator. So I'm going to start with 2 on the inside and 7 on the outside. Here we go. 7 does not go into 2. Put a decimal point. I can put a 0. 7 goes into 20 2 times. 2 times 7 is 14. Difference is 6. Bring down a 0. 7 goes into 60 8 times. 8 times 7 gives me 56. I have a difference of 4. Bring down another 0. 7 goes into 40 5 times. 5 times 7 is 35. The difference of 5. Bring down a 0. 7 goes into 57 times. 7 times 7 is 49. 1 left over. 7 goes into 10 one time. 1 times 7 is 7. I'm going to have to bring this up here. So I had 10 minus 7 down here. So what I'm left over with, I have 3 left over. Bring down another 0. 7 goes into 34 times. 4 times 7 is 28. 2 left over. Bring down another 0. 7 goes into 20 2 times. So now I'm back where I started, right? We started with 20 over here. We have 20 over here. So we know that this is the part of the decimal that's going to repeat. There we go. All right, letter B. 4 over 9. Same thing. 4 divided by 9. 9 does not go into 4, so put a decimal point. Bring down a 0. 9 goes into 40. 4 times. 4 times 9 is 36. Bring down a 4. And I could tell right there that I'm going to have the same number here that I'm going to have right here. So it's just going to be 0.4 repeater. Excuse me. All right. 3 divided by 11. Again, put your decimal point, bring down a 0. 11 goes into 30 now. It's going to go 2 times. 2 times 11 is 22. 8 left over, bring down a 0. 11 goes into 87 times. 7 times 11 is 77. 3 left over, and I'm back where I started. So it's going to be 0.27 repeater. All right, moving on to number 4. It says simplify. Draw a diagram to justify your work. We are going to go ahead and use those plus and minus tiles. So I'm going to start with -5. And I want to take away -6. So I want to take away 6 negatives. So when I go to take away 6 negatives, I only have 5 here. So what I need to do is I need to create an extra 0 pair so that I have a 6th negative sign to take away. I'm going to go ahead and circle my numbers in blue as I take them away. So I'm going to take away 6 negatives. And now, thanks to that one 0 pair that we had to make, we have +1 left over. So this is going to come out to +1. All right, letter B, I have 5 positives. 1, 2, 3, 4, and 5. And I'm going to take away 6 positives. So same thing as last time. I have to create a 0 pair because I don't have 6 positives to take away. And this time I'm going to circle the 6 positives and get them out of there. And this time I only have 1 negative left over. So it's going to be -1. C, we have 5 positives. And I want to take away 6 negatives. So in this one, I don't have any negatives. So I'm going to have to create a whole bunch of 0 pairs. So I'm actually going to have to create 6 0 pairs. So I have 6 negatives to take away. So I'm going to go 1, 2, 3, 4, 5, and 6. Didn't leave myself a lot of space here to work on. So I'm going to take away these 6 negatives. We'll do it 3 at a time because I can't really circle them all in one move. Now if I look at all my positives, I have my 5 original positives. 3 more gives me 8, and another 3 gives me 11. So +11. And finally, letter D, I have 5 negatives. 1, 2, 3, 4, 5. And I'm going to take away 6 positives. Just like C, we need to make 0 pairs. We need to make 6 of them. But this time I need to remove the 6 positives because I'm subtracting 6 positives and not 6 negatives. I'm going to have a very similar answer to the last one except with negatives. So 5 negatives, 3 more gives me 8, 3 more gives me -11. All right, moving along. Number 5, simplify, and we're going to draw a diagram similar to the last one. So we're going to go ahead, we're going to start with -3 and times -4. So the way we justified this in class, or what we called this, we said, think of this as taking away 3 groups of -4. So before I can take away 3 groups of -4, which is going to be 12 negatives, we know that, I have to create 0 pairs again so that I have something to take away. So I'm going to create 12 positives. Ooh, I ran out of space. Should be 12. And then 12 negatives. And what that allows me to do now is I can take away the 3 groups of -4. So let's find 3 groups of -4. So 1, 2, 3, 4. You're gone. 1, 2, 3, 4 is gone. And then this one too, which, sorry, it's all the way over here. I should have set that up better, but there's another group of -4 and they're also gone. And now I can see that I have 12 positives left behind. All right, letter B, 4 times -7, that's 4 groups of -7. So I'm just going to create 1, 2, 3, 4, 5, 6, 7. I'm going to do that 4 times. And 4 groups of -7 gives me -28. Letter C, this one has 3 numbers in it. So let's go ahead and we're going to start with -15 times -2. So we're taking away 15 groups of -2. Again, we're going to have to make a lot of 0 pairs here. So we're going to make -2. And we have to make those with 0 pairs. I'm going to have to do that 15 times. So it's 1, 2, 8, 9, 10, 11, 12, 13, 14, and 15. Let me just make sure that was 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So again, I made 15 groups of 0 pairs that are 2 each, right? Because I need to take away 15 groups of -2. So let's go in, we'll take away all those negatives. I'm not going to draw the arrows here, and we're just going to say those are all being taken away. And now what I have is I have 15 positives. But I need to, or sorry, not 15 positives, excuse me. I have 15 groups of 2 positives, so I have 30 positives. And then we're going to multiply by a half, so I only need a half of those. So I actually know that a half of 30 is going to be 15. So we're going to go and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that gives me 15 positives. All right. All right, number 6. Tried to do it all in one take, and I made a mistake. All right, so 0.17 times 5.05. I'm going to write it as 0.17 times 5.05. We're going to multiply. 7 times 5 gives me 35. Bring 3 over. 7 times 0 is 0, plus 3 is 3. 7 times 5 is 35. Bring it to 0. 1 times 5, 1 times 0, and 1 times 5. Add them all up. And now to figure out how many numbers go by the decimal point, I have to count how many are by the decimal point up here. 1, 2, 3, 4, and I move it over 4. So 0.8585. All right, B, same kind of thing. 4 times 6.2. I'm going to put the 4 in the bottom. I like to put the number with the least number of digits in it at the bottom so that I don't have so many numbers to add up on the bottom over here. Ignore that line, sorry about that. So 4 times 2 is 8, and 4 times 6 gives me 24. And again, I have one number by the decimal, so move it over, and it's 24.8. And we know that makes sense because 4 times 6 is 24, so it's going to be around there. And the letter C, 0.3 times 0.22. 3 times 2 is 6, and 3 times 2 is 6. I got 3 numbers behind the decimal, though, now. So I'm going to need to move this over 1, 2, and 3. And in that empty space, we put a 0. So 0.066. Number 7, write the following fractions as a percent without using a calculator. To be able to write these as a percent, we're going to need to write them as decimals first. So I'm going to go 7 over 5 is 7 divided by 5. We know that's more than 1, so I know it's going to go at least once. 1 times 5 gives me 5, 2 left over. 5 does not go into 2, so we put a decimal point. Bring down a 0. 5 goes into 20 exactly 4 times, so 1.4. I know that to go from a decimal to a percent, I need to multiply by a number by 100, so I'm going to move the decimal over twice, and that gives me 140%. All right, 4 over 3. Again, 4 divided by 3, we know it's going to be greater than 1. 3 goes into 4 one time. 1 times 3 is 3. 4 minus 3 gives me 1. I'm going to go ahead and bring down a 0. Oh, I'm sorry. Put a decimal point and then bring down a 0 because 3 does not go into 1. 3 goes into 10 3 times. 3 times 3 is 9. And watch what's going to happen. We have the same remainder here that we had before. So that decimal is just going to repeat. 1.3 repeater. Again, multiply your number by 100 to turn a decimal into a percent. I don't have a lot of space here, so I'm going to go ahead and write it over here. That's going to be 133, but then I'm still going to have that repeating decimal afterwards. So 133.3 repeater percent. Sorry, that's kind of smushed in there. All right, letter C. 9 divided by 14. Put the 9 on the inside, 14 on the outside. 14 does not go into 9. That's our first one that's not greater than 1. So I'm going to put a decimal point right away. And 14 goes into 90. How many times does 14 go into 90? 6 times. 6 times 14 would be 6 times 10 is 60. 6 times 4 is 24. So 84. Go ahead and subtract that. I end up with 6 left over. Bring down a 0. How many times does 14 go into 60? I believe it's 4 times. That's going to give me 56 when I multiply those. I have a remainder of 4. Bring down a 0. How many times does 14 go into 40? It's going to go 2 times. 2 times 14 is 28. Difference of 12. And we have to bring down another 0 another time. So 14 goes into 120 8 times. And 8 times 14 would give me 112. I had to think about that one for a sec. And I have 8 left over. Bring down a 0. How many times does 14 go into 80? Well, we said 14 went into 96 times. And that was 84, so we got to go one less time. So 5 times. 5 times 14 gives me 70. 10 left over. We're still going on. I gave you a tough one here. All right, so 10 left over, bring down a 0. 14 goes into 100 7 times. 7 times 14 gives me 98. And I have 2 left over. I'm going to bring this up here. So we had 2 left over. I'm going to put a 0. 14 goes into 20 one time. 1 times 14 is 14. Subtract it, and I have 6 left over. And 6 still hasn't come up. Nope, sorry. I keep thinking we're getting there. All right, so 14 goes into 60. Four times. Oh, no, wait. We did repeat this one. So now it's going to repeat the 4. My bad. Okay, so if you see right here, we had the 60 and we have the 60 right here. So we're going to repeat from this point on. So I'm actually not going to write it there because we know that it repeats at the 4. So when I convert this, when I multiply this by 100, this one's a little tricky. We're going to move this over 2 spots. And remember that the 4, 2, 8, 5, 7, 1 is the repeating part. So my percent is going to be 64. Sorry, this is ended right here. 0.28571, and then that 4 would repeat back here. So then that is the entire repeating part. Let's take a look. We'll check with our calculator just to make sure. So I had 9 divided by 14. There's the decimal that we had before, 642.871. Whoa, 8571. I guess this calculator, it's not going to show you that it keeps going on from that point on. And there you go, and that's a percent. I'm also writing on 2 pieces of paper right now. All right, number 8. Simplify 5 minus 6 plus 4 times 7 times negative 3. Use order of operations. Since this is in parentheses, I know 5 minus 6 gives me negative 1. These are all being multiplied, so 4 times 7, I'm going to go ahead and cheat a little bit with the calculator here just to help me out so I don't have to write these out for you. So 4 times 7 equals 28 times negative 3. So times 3 would be 84, but it's going to be a negative 84 because it's a negative times a positive. And 84, negative 84 plus negative 1 is going to give me negative 85. All right, letter B. 4 minus 9 times 2 plus 20 minus a negative 8. So 9 times 2 gives me 18. I know that minus and minus is the same as a plus, so I'm going to change that and write it as a positive. Helps me understand what's going on here. So 4 minus 18 is going to give me negative 14. 20 plus 8 is going to give me 28. And then when I add those two together, I end up with positive 14. Number C, negative 5 times negative 3 is going to give me positive 15. I'm going to multiply these numbers as well. 2 times 8 gives me 16. And 16 times 9, it's going to give me 144. 11 times negative 3 gives me negative 33. 14 plus 15. And I know that adding a negative is just like subtracting. So I'm going to subtract 33 from that, and I get 126. All right, we're almost there. Number 9, I got this whole long word problem here. It's about Mr. Goldman. He's going to his Bikram yoga class, and he has a backpack full of Go-Gurt. So his backpack contains 6 strawberry splash. Let's go ahead and underline that. 14 rad raspberries. 3 cool cotton candy. And if he reaches into his backpack and grabs a tube at random, what is the probability he will get strawberry splash? So we know our probability is the number that we want out of the total number. We have 6 strawberry splash. Those are the ones that we want. The total is 6 plus 14 is 20 plus 3 is 23. So 6 out of 23 will be his probability. And I don't think I have anything that will go into both of those numbers. All right, there you go.